Thanks, Jason. And great presentation. I think it's a great segue there. First, let me just say thank you guys for the invitation on behalf of the Water and Carbon Group. We're honored to be here and look forward to talking a little bit today about foam fractionation, the process of removing PFAS from complex waste streams. Look forward to discussing a little bit today on that. A little bit about the Water and Carbon Group. In 2007, based in Australia, we are actually now a fully U.S. company now. We got our start there, and we have been offering a portfolio of solutions for water, wastewater treatment. However, our keen focus is on landfill leachate space here in the States, where we solely focus on complex waste streams. As you can see a little bit of our history here. In 2007, we got our start. In 2017 is when the Water and Carbon Group started to play with foam fractionation. That was from a client standpoint for a need for a plant that was in Australia. The birth of that came the process that they patented called the leaf system. That then became the Shoal Bay leachate treatment system that is now still in operation, treating around 30,000 gallons a day of raw leachate for a complete system as well for PFAS removal. And then we came to the States around that same time and now have a full system here in the United States in Pennsylvania, treating between 50 and 100,000 gallons a day in Bethlehem landfill. In that course of time, we've also piloted 20 plus different types of leachates, and we have a dozen plus different projects in varying different stages. So on today's topic, we're going to go through a couple of the different agenda items here. We'll talk about the landfills landscape. You guys mentioned, everything kind of winds up back in the landfill, right? From the carpets to the soils that were spent to the paper products and everything. So everything winds back up in the landfill. So we're going to talk about the landscape there from their perspective a little bit and what happens to PFAS in the landfill. Talk about foam fractionation as a process from a theory standpoint. We'll give you a little overview of the LEAF system, and then we'll talk about the Bethlehem project, just a real-life, full-scale capital project. Talk about some of the implementation and costs associated with that project, and then conclusion there. What we're not going to talk about is the characteristics of PFAS. So those that are the organic chemistry folks in the room, I'm just going to assume that you guys are content with that knowledge base for right now. Other presentations will cover that handsomely, I'm sure. And we'll probably skip over the health implications of PFAS. I think those have been covered as well. So like I said, the PFAS, everything winds up in the landfill, right? So we've got food packaging in high percentages, in the 15 plus, million parts per trillion. We've got cosmetics, personal care, even your old, college cookware that's cracked and scraped and flaking is still in the landfill somewhere. So all those items are collectively stored, right, and placed inside the landfill. That ultimately breaks down through rain, and that water that comes out the leachate is then, as a passive receiver, is then elevated in PFAS contamination. And so that's why we're targeting and looking at ways to remove that PFAS from that complex waste stream. The leachate that comes out of a landfill is extremely complex. There's high levels of dissolved organic materials, humic and fulvic acids, high levels of total dissolved solids that create scaling. There's synthetic contaminants that are in landfills. All of these create major complex issues for treating. It just makes isolating and removing certain contaminants that much harder. So when we talk about leachate, it's typically a lower flow, but it's also extremely complex waste streams that range from site to site, from month to month, and in most cases are a lot of variables. And so it's not a one-size-fits-all scenario. So the technologies that are in place today These are just some, there's others out there, but some of which you can walk next door and talk in more detail with. But you guys have seen the granular activated carbon ion exchange out there, all of which have, these have pros and cons. Removes all PFAS to low levels. It's a simple process. It's non-selective though, but when it comes to a complex waste stream, they do tend to occlude a little bit, get a little bit heavy on the OpEx side because of that occlusion and exchange. You've got reverse osmosis, which creates a great barrier for removal. It also, it's non-selective more or less. It does great jobs of removing long and short chain. It does have a capital expenditure and OpEx is involved. There's also residual amounts to deal with as well. And then foam fractionation, which is what we're talking about. It is very targeted just with PFAS. It is isolating a surface active molecule. It's a lower CapEx option. It's a point source solution. And you can treat leachate without it being modified. So it can handle the raw leachate without any pre-treatment. It does not do a great job with short or ultra short chain PFAS molecules without any sort of additional chemistry. So from a basic theory, raw leachate, when it comes to foam fractionation, so raw leachate comes into what we call the foam fractionator, which is a cylindrical column. It is then introduced into a sparge gas, air, and what happens is that sparge air creates just millions of square feet of surface area. So there's bubbles, diffused air on the bottom, has the bubble surface area that creates surface area for the leachate. That leachate then creates a foaming, okay? The nature of PFAS is that being surface active, it likes to adhere to that interstitial space between air and water. So the surface area of the bubble and the foam is how the PFAS is removed from the leachate column. You'll see here, the raw leachate enters into the inlet air sparge from the bottom. The bubbles then come up from this diffusers, and then the hood collection, the foam is formed and is collected at the top, and foam residuals then slough off. The treated leachate then continues on. The leach system is a 3-stage process, continuous flow. So stage 1 is typically mainly for targeting longer chains. Stage 2 is targeting for shorter chains, and stage 3 for polishing. The reason that we do this is we try to isolate as much as we can in the first stage. About 98% of most all long chains are removed in the first stage. We can also identify certain co-surfactants or additives to start removing selective short chains if necessary after that stage. So in addition, we can control, the main thing that I didn't mention is hydraulic retention time, which is the time that the leachate comes in contact with the air sparge. So as long in each one of these systems, and it varies, and we have control of that, but typically 30 minutes per stage and gets the removal efficiencies. Now, depending on the leachate and depending on the complexities of the leachate and the goals that they're trying to achieve, you can go up or down from there. Ultimately, that third stage, then the foam is then collected and goes to a concentration step. This is an engineered model of the Bethlehem project that I mentioned. It's, if you look from the right to left, you see the 3 fractionators. So stage 1, 2, and 3. The 4th fractionator is the concentration step. That gets us to that 0.1 to 0.3 concentration of foamate. The tanks on the opposite side of the fractionators are where we store foamate for disposal. To the right, you have our blower arrangements and pump skids, and then we have a day tank to the right there. As I mentioned, we'll talk a little bit about the Bethlehem landfill. There's only a few full scale installations in the US. This is one. This was a site that is owned by Waste Connections. They had expansion projects going on at the landfill site. They had some local issues affecting them, but they were discharging to a local POTW. They did not have any regulation motivating them. There was no permit to push their decision to implement any sort of a capital project. This was proactive on their side. So this project was a bit unique. They've done this at other locations as well. And so, but the main reason was they were able to isolate and remove the PFAS from their leachate and to no longer disrupt downstream human or environmental health. This is not the finished site. This was the site. So this is a retrofit project. We took an old waste to energy plant and converted it. The gym in this picture is the building to the right-hand side. Everything else has been removed. From a project standpoint, the overview is, you can see the longest lead time item there was the permitting aspect. The regulatory and permitting took the longest approval time. The Water and Carbon Group oversaw the project as a whole. The first picture there shows the installation and construction of the secondary containment, which is like a 9-inch berm that went around the buildings for that to be assessed. Second, we started beginning in the installation. The third, you can see the first foam frac system tank being installed. And that last picture, you can see the line. So this system's been up and operational since June of 2024. So in that 9-10 month period, it's treated from, again, 50 to 100,000 gallons per day, all meeting level detection, below level detection contractual limits set forth by the contract, removing all the PFAS. Here's another picture of that engineered drawing that we saw. This is kind of walking into the doors. You can see the fractionators. For size reference, these are 6-foot diameter, 14 feet tall, if that helps. You can see the foam hood there on the top of the fractionator. Again, you can see the sampling is right to just at your eye level to the right in front of the pump skids. We try to make sure that, separate from, you hear a lot about remediation projects that are temporary or on site and you move. The Waste Connections facility, this will be in operation for decades to come. So the main thing that we wanted to take into consideration was long-term service and maintenance. With that consideration, being able to access things, service things, and have the ability to just easily and safely navigate throughout the system was the main design focus. And that's also the main feature that we have throughout the rest of the systems as well. Looking to the right, you can see the blower arrangement, and again in the pump skids there. The skids are actually manufactured, fabricated by PRM. So worked with some of those folks here. They have, and some of the other folks in the room, I believe, have been involved in the project. The day tank to the right, actually just since has recently been removed. So, but it was for additional storage. Typical performance. I mentioned the short chain removal efficiencies for foam frac are fairly low. So especially the PFBAs, without any sort of chemical addition or other surfactant addition. So with just long chain, again, we get great removal efficiencies. The PFSAs as well, we get great removal efficiencies. But when you start getting into the 4s, anything lower, the short and super short chain, you have to start having additional, either process or chemical add to get the removal efficiencies down to where you need. But just without any pretreatment, this is just raw leachate coming in, and these are the results that we're getting. With additive, and we're testing additives all the time. We have a current additive that's showing a lot of good promise. We can increase those removal efficiencies in the PFCAs and PFSAs, getting your PFBS down to 80%. Currently, we don't see any, regulatory issues that are going to hinder that or be a hindrance there for us in the short or near term, as well as on the PFBA. So there's not anything currently that will, that we see as being an issue, but there are other processes that you can implement post-foam frac to be able to achieve those goals. From a concentration factor, so after you remove the foam, after you've treated the water, so you've got raw leachate coming in, again, I said you got 50,000 gallons a day, you've got a concentrated liquid that you have to deal with, a 0.3 to 0.1% residual. So what do you do with that? So that comes out to around 50 gallons or so a day. So that's the straight process treatment. The next step there is, there will be other discussions, but you have options, right? You have residual management. So there gets into the destruction on-site, shipping off-site, or solidification. Short term is solidification for this particular site. We're working with a modified organoclay that's showing a lot of promise. That's getting a 10,000 to 20,000 X concentration factor. Essentially what that turns out to is, with our current daily flows, we're getting, about 2 gallons worth of a wet kitty litter type material to then be reintroduced back into the working phase of the landfill. This is the residuals discussion here, just that I touched on. The options for landfills right now, again, return to the landfill, permanently destroy, or do off-site management. The Water and Carbon Group is agnostic to this. We do not have a destruction technology. We do not have any legal partnerships with any destruction technologies. We are eager and hopeful that technology can, continue to develop and increase for those that are in need of it, and look forward to and working with several of them on advancing those technologies. I mentioned the Shoal Bay aspect. This was one of the first leaf systems or first foam fractionation systems put into place in the world. It also kind of shows a little bit more about the Water and Carbon Group in terms of aspect of what all we do. So the leaf system here is in this green building. This is a complete treatment system that treats around 35,000 gallons a day. Raw leachate storage, the leaf PFAS treatment system is the pre-treatment. So it is the first thing that the leachate comes into contact with is leaf. PFAS is removed, then it goes through a biological treatment process to DAF, to constructed wetland, then the treated effluent storage, and then to irrigation. So it's a complete system there from start to finish. Just a neat little proud project. Capital cost. So every site's going to be a little different, of course. Scenarios are different. But when we get into cost, there's a lot of mixed information out there in terms of what's accurate and what's not. So we've priced and budgeted a lot of projects already. So when we talk about the leaf system itself, we're looking at between $15 and $35 per gallon. So that's the daily flow. Okay, that's the capital cost for installed. For certain states, there's air treatment requirements. Those systems range from 100 to 150,000. You've got residual treatment. That's an option that varies considerably depending on which option is decided. And then buildings. So our preference is for long-term service maintenance and ease of navigating is to put it inside of a building. It's going to be there for a long period of time. There are containerized approaches that have a place. And if you have if we let the clients decide what they have, we do have containerized as well. But for larger scale, larger volumes of water, we believe that putting these inside of a building is the best solution for not only the people that are working on them every day, but also for the equipment as well, because you can control things a lot easier there. But from a cost standpoint, this will give you just some rough estimates. So again, for point source industrial pretreatment, this is a very viable option. Operating costs are very low. Actually, the low energy consumption, 4 to 6 watt hours per gallon. There's no use of typical chemicals other than if you have scaling and if you have the need for short chain removal. And then you have, if you decide to do solidification, there is additional there. And then the residuals are very low. So like I said, you've got 0.3 to 0.1% residuals to do in terms of management. So in summary, foam fractionation mostly focuses on hydraulic capacity. You're talking about contact time. It's not, I wouldn't say it's the premier solution, but it's quickly becoming a preferred method for complex waste streams because of some of the advantages that it has over some of the other technologies, not requiring any pretreatment, fairly rapid deployment, and low entry points. The leaf system summary is that it has, there's automation included. There's solutions from 1,000 gallons a day to over 500,000 gallons a day. And you have fixed plant designs for long-term solutions. We typically start most of our clients off with treatabilities or pilot studies. We have a scaled down version of our full-scale system and a trailer pull-behind version that doesn't require cranes or anything on site or site civil work. And this typically lasts about a week, gives us the information that we need, allows us to treat on-site leachate, gives a report showing the efficiency of foam fractionation for their complex waste stream, and also gives some education as well from the operator standpoint. That's all I got. Any questions?
Yeah, thanks. That's pretty impressive. I want to make sure I understand your flow process. So are you fractionating the condensate, or are you fractionating the leachate 3 times? So you're running the foam frac through the leachate. The first time, you said to remove the long chains. The second time, you're adding some amendment to move the short chains. Why don't you do that all in one unit? I've seen like Alonia's system, the SAF system, they do that all in the first unit rather than having 3 in a row.
Yeah, so we run, the leachate enters foam fractionator 1, and then it moves to foam fractionator 2, all right? And so we do that so that we can make sure that we start targeting different chains, different PFAS inside of those, each fractionator. So it extends the treatment time.
Are they the same fractionators? Or is there some different process that goes on in the second one? I'm just not sure why can't you add your amendments into a single fractionator to get the short chains along with the long chains?
It's the process that the Water and Carbon Group designs and has as a patent. The expectation, the removal efficiencies that we've developed is what they've come up with. In terms, each one is independently operated with independent blower and pump. So there's also contact time and height that takes into consideration. And there's also a foam control aspect that we can control with each of those fractionators as well. So it isolates each fractionator process so we can adjust it as necessary.
Okay, thank you.
All right, more questions? Looks like we've got one behind you there. I saw one to the right too.
Thank you. Do you see this as a viable option for inactive landfills? Let's say, from New York State, we have a lot of inactive landfills that operated in the 70s and 80s and have been privately owned and used as any random piece of land, from a library to even an ice rink. But obviously leachate still exists, but no active waste is being put in the land. So do you see this as a
great question.
temporary?
For the lower flows, yes, I mean, it can be used at closed landfills for lower flow environments. There are probably other technologies that might work better from an economies of scale, but it might work better for like a centralized area to be able to bring or haul to one specific point to treat several. But yes, it could work for a closed landfill as well.
I have a couple of questions. First of all, did I understand correctly? You are saying your treatment system is treating the leachate, but whatever you come out with as the final waste, you return back to the landfill. So basically, you are not reducing mass at all. Basically, you just concentrate it and return back to the landfill.
Correct.
I don't know why it makes sense to me at all, but have you think about the concentrate being destroyed, meaning the fomate?
I'm sorry, can you repeat that second part?
Have you thought about destruction of the PFAS in your fomate?
Yes, we're absolutely working with other destruction vendors right now. Like I said, the end goal is to have some destruction tech on site. We haven't isolated the right company yet to be able to do that, and that's also the client's indecision ultimately. But for now, the sequestration inside of the landfill is what was for the residual was what is certified and approved. So it's essentially utilizing the landfill for what it was made to do, which is sequester the waste.
I also have a follow-up question to Paul's question, because you mentioned you have 3 stages: long chain, short chain. Actually, you also have a polishing, if I understand correctly. What you do differently for your polishing step? And if you actually break into 3 stages, I assume you are going to generate more fomate, right? Because each stage you're going to have a fomate. So when you say the final 50 gallon is a combination of those 3 stages, or what happened?
I'm sorry, I'm having a hard time understanding the question.
For each stage, you have the fomate being generated,
Correct.
right? So you basically have 3 stages of a fomate being generated from fractionator, right?
Yes.
So basically, your fomate did not go through further concentrate. You just collected, it's 50 gallons you talk about in your presentation.
Yeah, the concentrated fomate is what goes into the 4th stage.
There's a 4th stage.
Yes.
Okay, all right. So what do you do differently for your polishing stage?
That's just the third fractionator is what we call a polishing. It's just additional HRT. It's just additional contact time.
We've got time for one more, and it's in the back there.
Thank you. Do you have an upper limit, for instance, if you've been at a site where there's a fire academy, fire ponds, and treating of maybe something 1,000 ppb, 2,000 ppb, is there when does it get too rich to work, or does it work every time for no matter what you put in it?
Your question is there a limit where it's too high? Well,
Right.
In leachate, we pretty much see, if you're in that second slide, you're not going to see anything, typically north of, 15, in that realm. But if you get into a very concentrated AFFF or something like that, that's where you'll see, higher elevations. We typically don't address those type of applications with foam frac. We try to, we stay with the leachate, which is
Okay.
going to be a range of what we can do.
Appreciate it. Thank you.
Yep, thank you very much.
Thank you again, John. So it's time for lunch. Hope everybody has a good lunch. Just ask you to be back here in your seats at 1 o'clock, and we'll start again. Have a great time.